Hi everyone. So I'll start by introducing myself. My name is Ross Williams and I'm a researcher working at Erasmus Medical Centre in Rotterdam in the Netherlands. I've been heavily involved the past few years with the patient level prediction working group within OHDSI, and as part of that we've decided to develop the OHDSI in Eden prediction model library. Basically what this will do is it will be a centralized repository where all of the prediction models that are developed under the OHDSI PLP framework will be deposited. The main reasons for this is that we're looking to increase the trust, the reproducibility, and the ease of understanding of PLP research. So over the last few years, lots of PLP models have started to be developed, and this is really great. However, if you want to go and find a particular model, then maybe you have to either find the paper or you have to search through various GitHub repositories. And this is all sort of quite time consuming and it's not very systematic. And we felt that it actually didn't display all of the prediction models that we developed with the sort of the shine and the polish that they deserve. So that's where the idea of the centralized prediction model library came from. And so what we're hoping to do with this is to make it much easier for prediction researchers to find prediction models that have already been developed, and then they can either validate these or they can test these or they can extend on these. The other idea is that if you are talking about, let's say, a regulator's perspective, then maybe they've seen the paper but they want to have a bit more information, or they want to explore the results themselves, or there's specific things that they're interested in. Or for instance, we often, when we will publish a prediction paper, we wouldn't necessarily specify a threshold of risk where we think that you should make your decision points at, but this is something that is going to be very specific to the use case, and so we leave it up to the people to the appliers, also in this case the clinicians or people that write the guidelines, and they might want to then play around with, well, what's the sensitivity and the specificity, and that's all going to be available within the prediction model library. So I'll take you through what we have so far. So I should say that this is still very much in the development phase. I'll take you through a demo app that we built within R-Shiny. We've actually moved over to a jQuery and responsive environment because that's going to make it a lot faster and a lot flowier, and sort of reduce some of the little holes that we got with R-Shiny. But this basically has a lot of the functionality. We'll be adding more functionality, so we'll be adding user accounts and we'll be adding different levels of control over, so we'll have people so you can approve, and in the end I think the idea is we'll hope towards some kind of approval process for PLP research where you can submit it and then you can get feedback and it will get approved, and then you can explore the evidence and you can upload your own evidence, and there'll be upload and download features. But I'll take you through what we have so far. So currently this is the landing page we have. We have some proposed developments that I'll talk a bit about later. But the library itself, now for those of you that are familiar with OHDSI patient level prediction research, you'll probably recognize this layout from what you get for each individual study. And the idea of that is to keep it sort of quite similar and quite aligned. So what you can do is you can say, hey, look, this is my development database, this is my validation database, this is my target population. So currently this is running off a database that we built to support this. And what that database allows us to do is, again, improve the speed, so we don't have to load PLP objects. We can just pull in the information that we need at the time. So this contains all of the information that is needed for one prediction model, and because the development and validation are the same, we know that this is an internal validation. As you've mentioned, all these results have come from a study that Jenna has been running, looking at predicting various outcomes following a COVID vaccination. So what we can see is we can say, oh, well, look, the AUC is pretty high on this. It's got a pretty big target size, pretty decent outcome count. So what I can do is I can select this and say, okay, well, I'm interested in the development settings, and then I can go here and I can say, okay, so I know this is a lasso logistic regression model. These were my starting points. I know what various other information that you might need. This is all sort of a little bit more sort of bookkeeping than anything else. You can look at the threshold dependence. So this is what I was talking about when I was saying you might be interested in, if I set a specific threshold, then what's my instance, what's my positive predictive value, specificity and sensitivity, etc. And then what I can do is I can also look at the discrimination. And again, this is all staying within the internal validation at the moment. This is actually running a little bit slowly, so this is why we're moving this across at the moment. So, and you can see here we've got various plots. So RSC plot, of course, precision recall plot, and then further looking at things like the F1 score, the box plot, and some of the prediction score distributions. What we also have is various calibration information, and again, so this is something that we've seen has been a bit traditionally neglected in the patient level prediction sphere, so we like to make a real effort of this. And here you can I can look, so currently we're looking at the train. I'll leave it at this just so we don't have to wait for it to load again. And you can see we've got these nice smooth calibration plots, and under here it shows you what the number of persons in each of these. I think this is now binned into 100 are, and then we can also see the calibration split by gender, so it's different demographics. And then what I'll show you is another nice feature that we've got that's added is the validation. And so what we see here are all the validations that are available. So the first line is telling me this is my internal validation, and then I can say, okay, well now I want to look at what happens in Germany, in Japan as well. And what that will do is it will add the information to our plots down below. And again, you can see it's a little bit slow, so this is really why we're moving across, but you can see now I can directly compare. So I can say, oh look, I can see that JMDC actually, this one goes over the top of my internal validation, so that's really interesting. And then IQVIA Germany, okay, so it's not quite as good. We're also getting some blockiness here, which is suggesting maybe there's not so many patients there. And then what we also have is the calibration plots, and we can see here that actually one of the problems we have here is because JMDC goes up so high, it blows out the plot. But we can see, let me quickly remove that. But what this does is it allows you to sort of more directly compare. So we can see that they're generally pretty well calibrated down at the bottom. And then what's also interesting to see is that IQVIA Germany doesn't actually cover as large a range of risk as CCAE is. And you can see this, so we can add in more, or you can remove different ones, and it will just give you a better ability to compare them. So, and lastly, we'll have a little bit of developer info. So at the moment, this was developed by Jenna, and this is the contact email for her. And so that's all I have to say about the prediction model library. We're hoping to get it launched by the end of the year. And if you have any questions, then you can email me. My email is r.williams@erasmusmc.nl, and my contact information will be posted where you can find this video. Thanks a lot for your time and attention, and I hope you enjoy the rest of the symposium.